So my name's Jed Deame with Nextera Video, and here to tell you a little bit about what is IPMX and where it fits. So first of all, what the heck is this IPMX thing? You've probably heard a little bit about it. It has something to do with 2110. I like to call it 2110 enhanced for beyond live production. 2110 works really well for live, but it's got some limitations. It's always assumed that the source is going to be the same format, for instance. It's always assumed that there's going to be PTP in the system. Well, what if we want to use it in environments beyond that? So with IPMX, we added some things to support Pro AV market, which is fixed venues, fixed installs, and also kind of low-end broadcast. I'd say low-end, but call letter, O&O kind of activities, non like top-tier distribution systems. So how do we do simplified use of video over IP? Some of the features: relaxed timing. PTP is not required. It could be used. If it's there, it'll be used. Supports compressed or uncompressed. Has encryption control for either HTTP or other custom types of encryption, and supports dynamic connections. What do I mean by that? It means you can actually change the resolution of your source as you're feeding the signal through the system, and you don't have to reroute it every time you change it. So a lot of nice features. So that's kind of in the nutshell. If you don't remember anything else other than that, memorize that slide. Where can it be used? Well, here's a few applications. This is a picture of our booth a couple years ago at Infocom that had some good examples. So there's a PTZ camera up at top. We had like an airport info kind of screen for distributed content through a large venue, multi-viewer applications. It could be used in a pub, some smart display modules, little things that will plug in the bottom of a display, and video wall applications. So those are a few ways they're used in Pro AV. Looking at, well, how does that map to maybe something somebody might use in broadcast? I just said, well, you can do a lot of the same things here. You got PTZ cameras in broadcast, right? You've got scheduling info that you might want to have distributed. A multi-viewer, of course, we have here, smart display modules, video walls. Hey, guess what? It's all the same kinds of things. So IPMX does have a pretty good fit in broadcast as well as Pro AV. Step back a little bit. Why do we do AV over IP? What is the landscape out there? In general, we're seeing more and more demand for it, mostly because of the scalability that it provides. You're not limited by router sizes and rack space and connectors and patch panels. So scalability, not only in number of connections, but also in resolution. You can go HD to 4K, 8K, and beyond. You're not always having to replace your connectivity infrastructure. But we have found there is a bit of confusion about the AV over IP standards out there. So we'll talk a little bit more about that. Some of the previous solutions or current solutions that are out there. SDVOE, some of you may have heard of. NDI is pretty popular in this space, Dante. But there's more to just those acronyms that we know. There's a lot of versions of each of these. There's HX2, HX3, there's Dante A, AVA, AVH, a lot of different versions of each of these, and they're not always compatible with each other, and so it ends up with a lot of confusion in this space. So this is one of the things that we're trying to address with a next generation video over IP system, is how do we make something that's scalable, interoperable, using industry validated codecs, not something that's tied to a particular vendor, and standards based, right? So there's lots of benefits of working with with standards over customs implementations, which we'll talk about. And also resolution independent is a nice thing because everybody's got different needs for the amount of data they're moving through their network. So we came up with IPMX. It was developed by AIMS, the Alliance for IP Media Solutions. It stands for Internet Protocol Media Experience. So a set of open standards that governs how video and audio are moved over IP. Looking at some of these other solutions that I talked about in a little bit more detail, I won't go through this whole chart because it's a bit of an eye chart, but if you look at things like the kind of Ethernet interfaces that are available, the other systems. There's some that are 10 gig, there's some that are 1 gig. IPMX, as you see, can handle really any type of network. It's network speed independent, 1 gig up to 100 gig. The codecs, a lot of these other ones are using proprietary codecs or proprietary variants, whereas IPMX uses JPEG XS, H.264, H.265, industry validated codecs that will be here forever, that aren't tied to a particular vendor. There's resolutions in here. We're not limited to any particular resolution. It follows the 2110 standard up to 32K by 32K. Latency is just a few lines. It also depends on the codec, right? So if you're doing uncompressed, it's a few lines. Otherwise, it's the latency of the codec itself, which could be 16, 32 lines, maybe up to a frame in some cases. The other big thing that's added is the security. So in addition to be able to doing HTTP, which, as we know, you can't really do in 2110, IPMX allows you to handle proprietary custom code ciphers. So you don't have to pay a HTTP license, for instance, if you want to be able to add a cipher to your content. We'll talk a little bit more about that. We're not tied to specific chips. This can be done in software. It can be done in FPGAs. It's a full open standard control system, NMOS, same thing that's used in 2110. Synchronization is there. It's optional. It's required if you're a transmitter in the system to be able to lock to PTP, but a receiver does not have to lock to it. And the quality, near visually lossless over 1 gig, completely visually lossless over about 2 gig, 2.5 gig. So really good efficiency. So touch a little bit on the open standards. Why do we need open standards? Well, although there's some smart people out there and individual companies, wouldn't it be better to just leverage the experience of the entire industry? People that have done this before. That's really what we did, building upon the experience of the people that developed 2110, bringing in some of the best and brightest minds to come up with the ideal solution that will meet the needs of the industry. Fosters multi-vendor interoperability. We've done a lot of interops, plug fests to really make sure that this will work out of the box. We want something that just works as kind of our logo. And we want the end customers that buy these products, we don't want them to end up in any kind of technology dead ends. A company gets acquired by another company, the technology might get disappeared or just end of life. That's not in anybody's best interest. So this is something that will survive any individual company, and allows the media companies to exploit the benefits of open markets. Some of the key technologies behind IPMX, as we mentioned, it's built on 2110, uses the NMOS control spec. There are a few different options for codecs along the bottom. This chart in the middle is a little view of what the NMOS control system looks like. I've got some more slides on that later on, but it is an industry standard. It is plug and play. So key difference, we'll dig into some of the detail between IPMX and 2110. How do we support this dynamic connection, which is one of the big features I talked about? Well, we have this capability called RTP sender reports. It's a different kind of message. In addition to the RTP, we have RTCP, real-time control protocol reports. So once a frame, the sender tells the receiver, here's my resolution, my audio sampling, here's some information about my clock, so that it makes it easy for the receivers to lock to this, in the cases where you don't have PTP, for instance. Compressed support, so there's additional extensions to NMOS to signal, is it compressed, is it uncompressed, which codec is it? That way the controller knows and can tell the user, source A is not compatible with receiver B, don't even try to connect it, I'm not even going to let you push that button. Adding the HTTP and PEP. PEP stands for Privacy Encryption Protocol, so 2 ways to protect your content. Things like HDMI info frames, which we don't have in the SDI space. We had to do a little bit of extra work for that. And USB to enable things like KVM extensions. We said it was an open spec. Where do you find the open spec? Well, you go to vsf.tv. They're all published right there. You can see the status. All the key ones are in final form. There continues to be other additions that we add. We're always adding additional capabilities to broadened the reach of IPMX, but the core set is in place. It's approved. It's all final. So what's the status of IPMX? Well, good news. I'm happy to announce, for those of you that didn't hear the announcement at the ISE show in Barcelona, it is a fully certified specification now. There are certified products. We did an event in January where we had many vendors show up, and we ended up with 48 certified products, and they all get this nice little logo here. They all have a unique identification number and a QR code. This makes it easy for the end user, the system integrator, to go to look at these things. You can make sure that the profile matches. So if you want to connect two of these systems together, you see at the bottom line the profiles listed. This one is the uncompressed and JPEG XS. If you find another box that says uncompressed and JPEG XS, you know they'll work together. If you see one that says H.264, don't necessarily expect it to work with the JPEG XS system. If you want all the details, you point your phone at the little QR code. They'll tell you everything about it, more details about its capabilities. So the point of this, again, is the just works connections. You don't have to wonder, will vendor A work with vendor B? It's certified. It's been tested. They've been through all the rigors to make sure this happens. A little bit more on the timing and synchronization side. PTP, as we know, is crucial in the 2110 broadcast space. We do fully support that in IPMX. As I mentioned, transmitters must lock to it if it's in the system. We also added a couple extra things like link offset delay. That allows you to do synchronization between multiple receivers. Certain markets might want to do things like a video wall, might want to have synchronized displays. So we built in extra capabilities to allow this. A little bit more about the JPEG XS codec. I mentioned a few codecs that are supported. This is the one that's the most popular. It's been around the longest. It gives you visually lossless at 10:1 compression ratio, which is around 2 gigabits, something like that. Very near visually at 14:1, which is 850 meg, which is a nice, comfortable number to fit in the 1 gig limit. Ultra low latency, just a handful of lines each direction, and a very small footprint. So it'll fit in FPGA cores. It'll run on an x86 as a software codec. It'll run on a GPU. So made to work both in CPU and hardware implementations. Okay, let's talk a bit about NMOS, the control system that makes all this work. NMOS is intended to be a plug-and-play control system. It supports products just connecting themselves to the network. What they do is they tell the controller that they're there, and then you end up seeing typical controllers that you might have seen in any kind of SDI router or HDMI router. It's, normal button panels, normal type of GUI displays, and it allows the user experience to be very similar to what they might have seen in a HDMI or SDI router. Let's go under the covers a little bit and see how this actually works. The very first step is you plug in your device. In this case, I've got two cameras on the left and a receiver, a monitor on the right. As soon as you plug them in and connect them, the first thing they do is they connect to the registry, that little hard disk looking thing in the middle. It's a piece of software running on a small computer, usually a NUC server, could be some rack-mounted computer. They identify themselves as part of the NMOS protocol. I say, hey, I'm here, I'm a camera, this is my vendor ID, this is my unique identifier, these are my capabilities. The registry gets that information, same with the receiver. Second step is your control panel, which is your control system, but whether it's a PC-based or panel-based, it reaches out to the registry with a very simple command and says, give me the contents of your registry, give me your database. So then the controller can see all the devices on the network, and guess what? It can populate the panel, whether it's buttons that have smart LED lights on them or whether it's a GUI, it can populate them, and then the user can just hit a button to do the connection. So the user hits the button, destination source take. What happens? It sends a command to the receiver, which is maybe not what you would expect. You think, oh, it's going to send it to that cloud-looking thing in the middle, which is the IT switch. No, it actually sends it to the receiver, and the receiver tells the switch through an IGMP join, Internet Group Management Protocol, to connect one of the streams, disconnect the previous stream if it's already there, and then connect the one that you want. Because the transmitters are always blasting away at the switch, but the switch is stopping the content until somebody asks for it. That's how you prevent from flooding the network. Okay, that's NMOS. So that's the NMOS ISO 4 and 05, the registration, discovery, and the connection. How have we extended NMOS for IPMX? Well, we added some additional capabilities called IS11, sender and receiver capabilities. And this is to ensure compatibility. In a 2110 system, everything pretty much works. You know, you've got 3 or 4 formats is most likely what you'll ever see. But in an IPMX system, it could be many different formats, different resolutions, different codecs, different ciphers, all that. So how do we handle that? And how do we handle understanding the capabilities of the display? Because typical HDMI or HDMI systems would be used that would have an EDID. So the first thing your monitor does is it tells the receiving device through EDID what its capabilities are. And that's combined with the capabilities of your receiving node. So in this case, it's saying, here's my display limitations, here's my gateway limitations combined. Things like, here are the resolutions I can handle, here's my preferred resolutions, here's my cipher and my codec that I'm using. And it sends it to the controller. So the controller now has some information about what this receiver is capable of locking to. And the first thing it does is it locks out any connections from incompatible senders. The sender does the same thing. The sender says, here's my transmitter capabilities. Here's what I can do. So the controller now has all the information it needs to make easy connections between senders and receivers, no accidental connecting an uncompressed sender to a compressed receiver. You can take it one step further if you want. Depending on the use case, you can say, I know what my receivers can do. Let me tell the sender my preferred resolution, my preferred mode I want to do. In this case, the underlined ones are the common denominators. So the controller could, if you enable this, you don't have to, you can tell the sender, oh, please send me 2160p JPEG XS HDCP, because that's the common denominator of all my receivers. So a nice feature for many applications. So in summary, IPMX is a solution for both Pro AV and broadcast markets. It's cost-effective, it's secure, it's an open standard. It enables deployment of video over IP without any huge IT burden. And that's one of the things that the call letter and no guys are really complaining about. I don't really want to have to bring in a PTP guru and a network guru. So these products are built to be a little bit more user-friendly to enable the reach of video over IP. You get beautiful 4K P60 over 1 gig Ethernet. You get security for both your control and the content itself. You can do encryption of the content and encryption of the control mechanism. And it leverages standards from organizations where people have been working hard for many years to really figure out the right way to do this stuff. It's open, not reliant on a single vendor, gaining lots of traction. We're hearing lots of good stories here at NAB about large deals that have been done, multi-hundred unit sales that have been going to different places around the world. Gaining traction, also adjacent markets, medical markets, government, military, finance, etc. And we won Best of Show at the ISE magazine from both AV Technology and SCN magazines. So that is what I have today. If you want to see it in action, please feel free to stop by our booth. We're right over above Canon in the central hall. We can give you a demo and talk in as much detail as you like. Thank you so much. We have about 30 seconds for questions, if anybody has anything. Yes, sir.
Are there open source implementations of these protocols?
Yes. Open source. Open source implementations. Some parts of it are available open source. I can't say there is a complete open source solution out there for you today, but for instance, some of the codecs are available that are open. For instance, you can read the specs of the codec, but you need to purchase a license if you want to use some of the proprietary pieces of it. So there's open, and then there's licensed. So there's versions of NMOS that are open, but maybe not with all the latest features, for instance. So if you want all the latest, greatest features, usually the commercial solution gives you the best solution. All right, are we out of time? Good. Okay, I think we'll have to end it. I'll be hanging around here for a few minutes. Please feel free to come up and I'll answer any more questions you have. Thanks so much, everybody.